Students, today we will learn how to recognize number patterns on the ASVAB. Look at this sequence, 2, 4, 6, 8, 10. What change happens each time?
2 to 4 is plus 2, 4 to 6 is plus 2, 6 to 8 is also plus 2.
That means the rule of the pattern is adding 2 each time.
Excellent, Becky. That's precisely it. Jaden, what's the next number in the pattern?
2 plus 10 is 12. This is an easy pattern. What do I do if I don't recognize the pattern?
Very good question, Jaden. Class, what are the 3 phases of inductive reasoning?
Observation.
Patterns, conjecture.
That's very good, Jaden and Becky. Observation of the numbers is the key starting place to find patterns. And once you see a pattern in the numbers, you can quickly have one of those aha moments, or as Sherlock Holmes would say, the game's afoot.
Indeed, the game's afoot.
These are the 5 steps to quickly move from observation to pattern to conjecture or suspicion. Jaden, when you take ASVAB, a pattern recognition question will most likely be multiple choice. Let's begin with step 1 on the board. We list and observe the patterns. Step 1 is to list and observe. Write out the sequence clearly before drawing conclusions. Students, these 5 steps help us recognize patterns quickly on tests like the ASVAB, but make sure the pattern you see holds true. Your conjecture must become a hypothesis to be tested. Step 1 is to list and observe. Write out the sequence clearly before drawing conclusions.
When I observe the numbers, what do I look for?
That is a great question, Becky. Jaden, do you know the answer? We look to see if the numbers are rising, falling, doubling, or evenly spaced.
Observe the patterns, Jaden.
Jaden, every mystery begins with observation. Patterns reveal themselves to the careful mind. Observation. First, observe the direction. Are the numbers rising or falling?
They're rising.
Good. Now check the difference.
Plus 2, that is my conjecture. Yes, you have your observation, pattern, and conjecture.
Observe the direction, Jaden. Are the temperatures rising or falling?
They're falling.
And by how much each hour?
5 degrees. Correct. If the
How much each hour? Right. Correct. Consistent patterns allow us to predict dangerous conditions. All right, step 1, list and observe. Do these numbers look evenly spaced?
Yes, each one goes up by 5.
Exactly. So what test should we select?
The common difference test.
Correct.
Well
Are the
done.
gaps between numbers equal?
Yes, 5 each time.
Then the pattern is adding 5. So the next number is 25.
Apply the common difference test.
Notice how quickly the numbers grow.
Addition doesn't explain it.
Exactly. Try multiplication.
Each number is doubled, so the next number would be 48.
Observe the colonies, Jaden. Staphylococcus aureus can multiply rapidly on a blood plate. What pattern do you see?
They triple each time.
Rapid growth often reveals multiplication. When one rule fails, consider 2 rules.
Multiply, then add?
Yes, 2 alternating rules. Look carefully, Jaden. Do all the numbers follow one simple rule?
No, 3 to 6 looks different from 6 to 7.
Excellent. That means one rule may not be enough. Now examine each step. What happens from 3 to 6?
That is multiply by 2.
And from 6 to 7?
That is add 1.
Continue the pattern, Jaden. What happens from 7 to 14?
Multiply by 2 again.
So what kind of pattern is this?
2 alternating rules. Multiply by 2, then add 1.
If the pattern is multiply by 2, then add 1, what comes after 14?
Add 1. The next number is 15.
You have solved it. Recall the pattern, Jaden. Multiply by 2, then add 1.
14 plus 1 gave 15.
So what happens next?
15 multiplied by 2?
Precisely, alternating rules. Every pattern follows the same reasoning, Jaden. First, observe carefully, then test the pattern. Observe, test the pattern, then predict.
When observing numbers, we often instinctively examine their differences. That is the next logical step.
First, observe the number. Second, check the differences. And third, if differences fail, check ratios.
Precisely, well done, Jaden.
When we examine a pattern, we follow a logical process. First, observe the numbers, then calculate the differences. If the differences between numbers are not consistent, we test for ratios. That means we check whether each number is multiplied by the same amount.
So instead of subtracting, we divide one number by the next.
Yes, that helps us detect multiplication patterns.
Like when numbers double or triple.
Exactly, those are ratio patterns. Here the differences are not equal, but each number is twice the previous one, so the ratio is 2.
Okay, step 3 is to test for ratios. 6 divided by 3 is 2, 12 divided by 6 is 2, and 24 divided by 12. So the pattern is multiplying by 2. The next number is 2 times 48, which equals 96. Let's test the ratios again. Each number is twice the one before it, so we double 40.
Excellent reasoning, Jaden. When the ratio stays constant, prediction becomes simple. Sometimes the pattern is not doubling. Instead, we test the ratio between the numbers. Divide each number by the one before it. The ratio stays the same. Each number is multiplied by 1.5. If the rule is multiply by 1.5, then we apply the same rule again. So the next number is 20.25.
So the next number is 20.25.
Very good detective work begins with observation, Jaden. This pattern is not simple addition or doubling. Try testing the ratios.
Let me divide each number by the one before it. The ratio stays the same. Each number is multiplied by 1.5. The ratio is 1.5. So we multiply 27 by 1.5.
There is a faster way to recognize this pattern. Multiplying by 1.5 means adding half of the number. Add half the number, and the pattern reveals itself immediately.
Wow, that is a great memory trick. Let me test the ratios. Each number is half the previous one. If the rule is divide by 2,
Excellent. Ratios may also shrink the pattern. When the differences fail, Jaden, test the ratios. Some patterns grow by multiplication, some grow by fractions, and some shrink. The rule is simple. Observe, test, then predict.
First, we test the differences. These differences are not consistent. Next, we test the ratios. The ratios are not consistent either.
wait, something repeats. 3 to 6 doubles. 6 to 7 adds 1. 7 to 14 doubles again.
And 14 to 15 adds 1. so the pattern alternates.
This is called an alternating pattern. Two rules take turns.
Once we discover the pattern, we must state the rule that produces it. The rule explains how each number leads to the next.
The numbers double each time, so the rule is multiply by 2.
Now, consider this sequence. The difference is 4.
So the rule is add 4 each time.
Excellent, Jaden. That's the general rule. A good rule must be clear enough that anyone can continue the pattern. State the rule, and the sequence reveals itself. Once we have formulated the rule, we must test it. A rule is only useful if it predicts the next number. Observe the pattern. What's the rule?
The rule is multiply by 2. So the next number should be 64.
Excellent. The rule has been verified. Today you practiced an important kind of reasoning. When we observe patterns and form a likely rule, we are using inductive reasoning. Once the rule is known, we test it by predicting the next result. That is deductive reasoning, applying a rule to reach a conclusion. Now discover the rule, then predict.